Okay, YouTube, this is my first video in our module on solving rational equations. And so just kind of bringing up what we mean by this, we have equations that involve some rational expressions, maybe some algebraic expressions on top and bottom, maybe something like this here, plus 1 equals 4 over x minus 2. But certainly solving for x in a situation like this would be a little bit more involved than solving for x in a situation where you don't have rational equations. And so what we're going to do is explore just kind of the techniques behind solving things that are in this form. Starting with a method that we use that is cross multiplying. Okay, and so let's go ahead and bring something up here. We say that we can use cross multiplying to solve a rational equation when each side of the equation is a single rational expression. And so one thing that I want to mention here is this. When we say that a ratio is equal to another ratio, then what we're saying is that these two things form what we call a proportion. And with proportional math, the certain I guess thing that always follows is if you have a ratio equal to a ratio, then A times D is always equal to B times C. In other words, you get this cross product right here, A times D always equaling to B times C. And just to bring up I guess a simple set of ratios here, 2/3 is 4/6. This is certainly true. But I just want to show you that if you had two equal fractions here, like we get, we get a cross product of 12 here, and we get a cross product of 12 here, then certainly we could say that their two cross products have to be equal. So that being said, our method of solving, I guess, a rational equation where we have a ratio equal to another ratio directly is to use a cross product and set the cross products equal to one another. So what we're going to see here is this. 3 times 4x plus 5, this would be our cross product down this way here, has to be the same thing as 9 times x plus 1, okay? And the reason why is because they are proportional. So let's go ahead and do this. We're just going to go ahead and solve this equation by simplifying here. We get 12x plus 15 on the left side. On the right side, we get 9x plus 9. And as we solve for x here, if we subtract 9x from both sides, of course, we get 3x's left on the left side, 3x minus, or plus 15, pardon, equals 9. And then the last things we could do here, we'll just go ahead and subtract this 15. I think that leaves us with a negative 6 here. And dividing by a 3, we get a negative 2. So this would be really easy to check by plugging it back into the original equation, and that's certainly something that I do want you to see here. If we would put a negative 2 in here for all of our x values, we get 9 over 4 times negative 2 plus 5. I guess what I'd like us to see is that on the left here we get 3 over, I suppose this would be 3 over a negative 1, which comes out to be a negative 3. And on the right side here, we get 9 over a negative 8 plus 5, which comes out to be a 9 over a negative 3, which comes out to be a negative 3. So we do have equality here, okay? And the other thing I want to mention is that once we find our solutions here, we do want to look at the original expressions and come up with any restrictions that we need. And so looking at this denominator here, we have an x plus 1. This would mean that our x value is not allowed to be a negative 1. And because 4x plus 5 is also a denominator here, if you set that equal to 0 and solve it, we get negative 5, 4. So these are two x values here that we could not include in their domains, and that certainly wasn't the x value that we found in our solution here. So our solution is good to go. We say that negative 2 is indeed the thing that solves this. So what I'd like to try is just kind of this method again here. Just a few more examples. Let's take a look, and then we'll have some have you try some on your own here. So number one, we have another proportion here. We got a ratio equal to another ratio. So let's go ahead and run our cross product. We get 3 times x minus 7 is equal to 2 times 5x. So simplifying both sides, we get 3x minus 21 on the left. Here we get 10x. It is the case that we do want to get all our x's on one side. So as we subtract the 3x over, we get negative 21 is equal to a positive 7x, which leads us to the conclusion that x must be a negative 3. And it'd be really easy to check here now in terms of restrictions, okay? We cannot have an x value, it seems, of 0. If 5x equals 0, then x equals 0. And if x minus 7 equals 0, then x is equal to 7. So these two x values are restricted, and those were not any of them in our solutions list here. So what I want you to do is give numbers 2 and 3 a shot here and see what you come up with, and plug them back into your original equation to check to see if they work or if they don't work. Cheers.